Thank you very much. It's fantastic to be back in Brisbane. If somebody had said you'll be in Australia at the end of this year, at the start of this year, I would not have believed them at all. So C4 models as code. Architecture diagrams, traditionally terrible. We all know this, we've all seen it, we've all done it. Nobody wants to use UML anymore for a whole bunch of different reasons. Enter the C4 model. So the C4 model basically says this: if you do want to stick with boxes and arrows type diagrams, make sure you do so in a structured way and try to use a self-describing notation. And the C4 model is essentially two things. It's, number one, a set of abstractions, a set of hierarchical abstractions, software systems, containers, not Docker, components, and code. And it's a hierarchical set of diagrams that essentially map onto that set of abstractions. And the concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you do a Google map search for Jersey, you'll get that picture. That's great if you want to know where the important things are in Jersey, but for many people, it's too much information too quickly. We've zoomed in too fast. How do we fix this problem? We pinch to zoom out. So really, this is different levels of diagrams that allow you to tell different stories to different audiences. That's really the concept here. So the top level in the C4 model is called the system context diagram. And in order to draw a system context diagram, you need to answer these questions. So what's the thing we are describing here? What's the system we are describing? What's the scope of that system? So what features sit inside the system? What features sit outside the system boundary? What types of users, roles, actors, personas are using this system, and what types of things are they doing? And what are the system integration points that we need to support? So if you answer those questions, you can draft up something like a system context diagram. And here's an example from a workshop I ran. The red box representing the financial risk system is the thing that this group were designing. They've correctly identified a couple of different user types, and they've identified a bunch of systems that sit in the existing environment. So that's a really nice example of a system context diagram. Got some color coding, you can read the writing, got a nice little diagram key in the top right corner. So now what we do is we pinch the zoom in that red box, and we drop down to level 2. And level 2 is a container diagram. There's an unfortunate clash of naming here. I got the name first, but that's irrelevant, of course. By container, I basically mean an application or a data store. So in order to draw a container diagram, it's a different set of questions that you're answering. What are the major technology building blocks? So what are the applications and data stores that make up our system? What are their responsibilities, and how do they communicate with one another? Answer those questions, and you can draft up something like a container diagram. So what this group did is they zoomed into that red box. We're still showing people, we're still showing the systems that sit around the outside of that red box, and now we're showing a bunch of applications and data stores that make up that software system. And that's really the C4 model in a nutshell. It's notation independent, so you can use any style of boxes and arrows and colors and shapes you want to, and you could, in theory, use something like UML as your notation, along with the richer semantics that something like UML provides you. So tooling. What tooling do I recommend? There's a whole bunch of tooling I've listed on the c4model.com website, and I've tried to break it up into different categories. Most people, of course, are using general-purpose diagramming tools. Who's using general-purpose diagramming tools? Right, please don't do that. Please stop using general-purpose diagramming tools like Visio, etc. These are fabulous tools, right? I love these tools. They're super sophisticated, but I don't recommend them for software architecture diagrams. Why not? They don't know what you're trying to do. So with a system context diagram, you should really be only showing people and software systems. Because a tool like Visio does not know you're doing a C4 system context diagram, you can add something like a component to a context diagram. So the C4 model doesn't have many rules, but that's one of the rules. Don't add components to a context diagram. So Visio can't help you. If you want multiple diagrams at multiple levels of abstraction, you have to copy-paste elements across your canvases in tools like Visio. If you rename one of the people, in this example, you need to make sure you rename it everywhere. The tool's not going to help you do that. And if you don't do that, your diagrams drift out of sync. This needs no explanation. If you tried to export many of these formats to a text format to stick it into Git, you get everything. Content and presentation is very mixed together. That also makes it hard to diff, so you can't include these things in pull requests. And you can't automate many of these tools. With diagrams.net, you can feed it a CSV file, and you can do some basic diagram generation, but fundamentally, these tools are quite hard to automate. Yeah, and they're really time-consuming, because you'll draw a bunch of boxes of what you think are the right size, and then you put all the text in, and then the text will overhang one box. You go, Should I just resize that one box, or should I resize all boxes? And then you go, I'll resize all boxes, and that takes forever. And then you find you can't align the arrows. If you look at this diagram here, that arrow is not straight. It's 1 pixel off. It's really annoying. So, October 2020, the ThoughtWorks Technology Radar blipped diagrams as code. Diagrams as code is essentially a way to craft up diagrams using a textual format. PlantUML, Mermaid, Graphiz, and Dot, for example. So what you do is you write up a bunch of text, you feed it through a tool, and the tool generates you some diagrams. Most of these are automatic layout focused. This is really nice because as developers, we like text. These things are text. We can diff them, we can version control them, and many of these tool chains are integratable into CI/CD build pipelines. So these are really easy to automate in many cases. The one that people kind of fall on first with regards to the C4 model is called C4 PlantUML. And this is essentially a set of extensions and macros on top of the PlantUML syntax. So what you do is, rather than talking about rectangles and arrows, you're talking about person and software system and relationship. So here we can see that we've got person, system, relationship, and this little bit of text here, which kind of looks C4-ish, generates you this little picture. So that's nice. It's a nice way to get started in all of this tooling. The problem with PlantUML is that it's still a diagramming tool. If you want to create a system context diagram and a container diagram, you need 2 text files. And if you're going to share elements across those 2 text files, you now copy and paste lines of text across both text files. Sure, there is an include mechanism, and we can use the global search and replace in our IDEs to make this stuff easier, but fundamentally, if you want 2 diagrams, you've got 2 text files. So you, again, have to make sure you keep things in sync. I want to switch the narrative. I want to go back to what we used to do 20 years ago, which is modeling. Now, when I say modeling, people get really scared and run out of the room because they think rational rows, rational software architect, those horrible yellow boxes, purple borders, lots of big design up front. That's not what I'm talking about here at all. The concept of model is really powerful. So, lockdown happens. I live in Jersey. I got locked on the island. There's only so much surfing I can do, and I learned how to make nice coffee, and that was all great. But I needed to fill my time with more things, so I built a bunch more tooling. And really, that's what this talk is all about. And the core of this is called the Structurizr DSL. And it's a text-based domain-specific language that I built specifically to create diagrams based upon the C4 model. And it's model-based. So what you do is you craft up one single text file, and you can generate automatically a bunch of diagrams off the back of this text file. And that's the concept of a model. A model is essentially a central dictionary of elements and relationships exposed and surfaced on views, diagrams. And when you change the name of those things in your dictionary, in your model, your views get automatically regenerated, and they're all magically in sync. That's the power of a model. So this is really models as code, and of course it's C4 models as code. So I'm going to stop the presentation here and jump straight into a bunch of demos. So I'm going to show you a bunch of tooling that I have created, and also that other people have created around this. And everything I'm going to show you is free, unless I say otherwise. So the first bit of tooling I'm going to show you is called Structurizr Lite. Structurizr Lite is a free version of my Structurizr tooling. It's a kind of client-server-based diagramming tool, runs in the web browser, creates you a bunch of interactive diagrams. It's available as a free Spring Boot app you can download from my website, or as a pre-built Docker image. So what I'm going to do is I'm going to start up Lite against a folder that does not yet exist on my desktop. So let me show you my desktop. There's my desktop, it's empty. I do have a folder called From Desktop in my Documents folder, but we'll ignore that. We've got to clean the desktop somehow. So I'm going to start Structurizr Lite up against that folder. And Structurizr Lite is going to create that folder for me. And inside this folder is a workspace.dsl file. And this is the Structurizr DSL. So the Structurizr DSL is another open source project that I created. This is all on GitHub. And with the Structurizr DSL, what we're basically doing is we're defining a workspace. And a workspace is basically a wrapper for 2 things, a model and a set of views. So the model here basically says, I want to define a person with the name user. Please don't do this, make up a better name. It says we want to define a software system with the name software system. Again, same advice. And we're going to create a relationship between the user and the software system with a description of users. And again, if you've seen my talks before, please don't use users either. But this is just a template. So that's my model. We've got a person, a software system, and a relationship. And down here, we're saying I want to create a system context view for my software system. Include this, it's just a diagram identifier. We're going to say include star. So what include star here does is it says, right, you want a context diagram for the software system, and the star bit basically goes and finds all of the people and software systems that have a link to that system and includes it on the diagram and apply automatic layout. So if I now go to my web browser and open up Structurizr Lite, always accept T's and C's. This tool is actually, it's free, but it's going open source next year, so the ULA thing will go away. And there we go. There's my diagram. It's amazing, isn't it? I can feel the enthusiasm for my 2 gray boxes and 1 arrow. Spectacular. Thank you. That was a quick talk, wasn't it? So that's the Structurizr Lite. So it's a kind of JavaScript single-page app thing running in the web browser. So let me show you a bunch of things. I don't like automatic layout. So when I'm drawing an architecture diagram, I like to move boxes where I want to move boxes. So I'm going to comment that out, go back here, refresh. And now we can do things like, you see a bunch more buttons appear. We can move boxes around. We can add line breaks, change the line routing. We can move the text up and down. So we've got a lot more control over the layout of this diagram. Now, some of you might be thinking, well, hang on a second. Where's the layout information? Because it's not in here. And you're absolutely correct. The layout information is in this JSON document, which is stored next to the file. And this JSON document is described as an OpenAPI 3 Swagger definition. It's all, again, open source on GitHub. And this is the canonical data format used by this and associated tooling. And really, this is just a JSON version of that model. So here we've got our user. Here we've got our software system. We've got our views, and you'll see a bunch of width, height, and the XY coordinates. So what you do now is you take this whole folder, you dump it into source code control along with the scripts to boot this tooling up, and now anybody on the team on demand can boot these diagrams up and modify them as necessary. So that's that. And what I'm going to do now is I'm going to go back to here and put automatic layout back on. I'm going to go left, right, because it looks nicer on a screen. There we go. So imagine this is my context diagram. How do we add a container diagram to show containers inside the software system? Well, what we do is we open up a set of curly braces, and we say, right, let's have a web app. That's going to be a container, a C4 container. We're going to call that web app, and we're going to have a database. That's going to be a container called database. And I'm going to say that the user has a link to the web app users. And the web app has a link to the database. Let's do reads from and writes to. So if I save this and refresh my browser, what do you think is going to happen? Any guesses? I can see people going, nope. The answer is nothing. And the reason nothing happens is because I've added these things to my model, but my model is non-visual. In order to get a diagram, I need to add a view. So how do I do that? Well, the view I need now is a container view. So I can copy this bit of text here. I can change that to container. So we want to create a container view for the software system. I'm going to change my diagram identifier. Include star is now going to say include the containers inside that software system and find the people and software systems that link to them. So that's going to do something different. If I go back here now, refresh, now you'll see there's a little plus symbol. Now we can double click this, like the pinch to zoom feature, and we get our container diagram. And it's just rinse and repeat. You can kind of add more things. The interesting thing with this whole include star is that there's a little expression language built into this, which is all described on the language reference page. So we can do include user web app DB, and that will give us the same thing. We can break this up into multiple lines. It will do the same thing. We could do something like include the web app, things coming into the web app, and things coming out of the web app. So that gives us the same thing. And we could do something like elements.parent equals software system. Let's see if that works. Yeah. So there's a whole bunch of ways you can essentially get to the same thing. So what you have here is essentially an in-memory object model of people, systems, containers, relationships. And you can use this expression language to kind of navigate that model, which is quite nice. So who likes gray boxes? No one. So let's fix the gray boxes thing. How do we make the boxes look nicer? You have a bunch of options. The first option is to use a theme. So there's support for themes built into this, and there's a default theme, which makes all of the boxes go blue, different shades of blue. So that's option 1. But let's not do that. Let's go back to our gray boxes. I'm going to turn tooltips on, and if I hover over the user, you'll see a couple of words. There's element and person. These are essentially text-based tags. So the user has an element tag and a person tag. The web app has an element tag and a container tag. Ditto the database, and relationships have a relationship tag. So this is really just like HTML and CSS. You craft up a div, and then you add a bunch of CSS classes, and then you craft up some style sheets to style those CSS classes. And essentially, it's the same thing here. So if we want to change the color of all boxes to, since this is the red room, let's go red. We can do styles. We can create an element style for the element tag. So this will get everything. And we're going to do background red, dark red, and color, text color white. So this should be fairly familiar. There we go. So now we changed all the color of all the elements in one go. If we want to change the user to a person shape, we can now add another style for the person tag on its own. And we can do shape person. Now we have a person. And let's change this database to be a cylinder. Well, if I add tooltips, the database element has an element and a container tag. So we can't change all elements, and we can't change all containers. So we need to add a specific tag for the database. How do we do that? Well, what we do is we go up here, we open up and set curly braces, we do tags, database, and then we go down here, and we do the same thing again. Element style for the database tag, shape cylinder. Bingo. One of the things you would have seen on my c4model.com and when I do my workshops and talks about the C4 model is when you're drawing architecture diagrams, make sure your notation is self-describing. How is this self-describing? Well, it turns out this tooling generates your diagram key automatically based upon the tags and the styles. So that's one of the tasks is now completely taken out of your hands. You can have this automatically generated diagram key, which is quite cool. The other thing you can do with this tooling is you can start to do things like animations. So whenever I present an architecture, I often want to walk through my diagram box by box and kind of tell the story as I go along. So let's do that. So let's have an animation, which step 1 is the user, then the web app, and then the DB. And we can go here, refresh, and now you see a bunch of buttons down here. And if I step through, we get the animation. So this is a nice, really way to create some kind of interactive architecture diagrams. And there's a whole bunch more stuff you can do here. You can add additional metadata and properties that will show up on the element properties and the tooltips and so on and so forth. Things you can do with these diagrams, you can export them to high-res PNG files. So again, this tooling is all free. Just start it up from Docker Hub. You can include the animation steps, so you can get 1 frame per animation, and you can create an animated GIF as well if you want to. So that's the kind of export side of things. You see that all. There you go. There is an SVG export, so if you want to dump out an SVG file and it's got a bunch of JavaScript event handlers in there for double-clicking events, you can do that as well. And there is an offline HTML file that you can use if you wanted to send around a single file to your colleagues with the diagrams in, including the diagram keys. So that's kind of a quick intro to the Structurizr tooling. So I'm just checking my notes here, make sure I've gone through all the cool stuff. Implied relationships. One of the things we talk about in software development is dry. Don't repeat yourself. But you'll notice if I go back up here, I literally have repeated myself. I've said that the user has a link to the software system, and the user also has the same link to the web app. It's duplication. How do I fix this? The answer here is delete that one. So if I go back and now refresh this, so we still have the user to the web app and the web app to the database. Those are the relationships defined on these 2 lines. But if I go back up here, now this relationship still exists. So this is a feature called implied relationships. Because we have a model of elements, and those elements are hierarchical by nature, because there is a link between the user and the web application, and the web application sits inside the bigger thing, the software system, we can imply that there's a relationship missing from this model, and we can add it automatically. And there's a whole bunch of ways you can customize this. You can drop out to Java code and write your own strategies, and you can disable this entirely as well. So this is a really nice feature that allows you to kind of trim down how much code you're writing in this case. So we've done all that stuff. So let me shut down our little example. and I'm going to boot up a different set of examples. If any of you have been to the c4model.com website, you would have seen a bunch of example diagrams for the internet banking system. So let's boot that example up. Structurizr Lite. So here we have our full screen. System landscape diagram, double-click, get to system context, double-click, get to containers, etc., etc. Now, one of the criticisms with the C4 model and the approach here is there's lots of text. So I'm a big fan of putting descriptions and text, explanatory text, on my diagrams. But sometimes you might want to remove that text because you want to do a presentation, and you don't want that text kind of distracting your audience. With a tool like Visio, what do? You take a copy of this whole file, you open it up, you double-click in all the boxes, you delete all the text, and then you kind of recenter everything. In this tool, you basically say, OK, I'm just going to turn descriptions off. And if you want to hide the metadata, same thing. So now you can do your presentation with the animations with that different version of the diagram. So again, this is the model plus multiple views approach, which is quite nice. So the Structurizr tooling supports all of the diagrams you see on the c4model.com website. So let me shut down Structurizr Lite, and let me boot up another tool called C4Viz. So C4Viz is another open source tool. You can find it on GitHub. And it's essentially a kind of version of Structurizr Lite that renders diagrams in a different way. So here's a question. Why is my Docker container not working? It's taken too long to start, so I'm going to do that and restart it. There we go. If in doubt, delete the container, start up again. I have no idea why. The fun of Docker. So now I'm going to go here and go to C4Viz. So this is another type tool. It's another kind of browser-based tool for rendering diagrams. We're rendering the same views, but now we're using the PlantUML tooling. So this tool has the PlantUML tooling kind of built in. And it's also interactive, so we can go system landscape, to context, to containers, to components. So again, same sort of thing, just using a different visual style, essentially. So that's C4Viz, which is quite cool. That's all open source as well. Let me shut that down. And let me open up yet another Docker container. So this is called the Structurizr site generator. For those of you who went to Aino's keynote yesterday, she mentioned when she talked about the cognitive load thing, that some people thought the little diagram was the important part, and some people thought the text was the important part, and how some people learn textually and some people learn visually. This is kind of the same thing. So the Structurizr site generator, you point it at a workspace, and it generates you a nice little kind of HTML microsite of all of your things in your workspace. So you click software systems, and you get like a textual list of all of your software systems. We can click on those things. We can see the diagrams associated with each of the different elements. And what we can do, which is quite nice, if I go back here, we can click on something like the email system, and it takes us to the textual description for that. So with this tooling as well, you can also embed Markdown and ASCII documentation. You can build quite a nice kind of rich microsite of documentation, which is also quite nice. So that's Structurizr Lite, C4Viz, and the Structurizr site generator. So you have a bunch of different ways that you can render these diagrams. So let me shut down this one. Also, some tooling I built during the pandemic was a Structurizr CLI. This is, again, it's an open source thing you can find on GitHub, and it's a command line interface for dealing with those workspace files. So I have it installed here locally, and what I can do is I can say I would like to export the workspace at, which one should we use? Let's use the YOW version. I would like to export the workspace at desktop YOW workspace.dsl, format PlantUML. So this is going to basically find all the views you defined and export them to PlantUML. And if I open up my Finder again, we'll see there are now a bunch of PlantUML files here. And if I open up that one, so it's generating you PlantUML. So it's generating a bunch of PlantUML diagram definitions from that single source. So every time, again, you update your DSL, you generate this thing, and you get a whole bunch of in-sync PlantUML documents. So what we can now do, of course, is we can take this, we can open up an incognito window for reasons of advertising. We can paste this in here, click submit, and then we have a PlantUML version of the little context diagram we built before. See all the ads pop up now. So let's kill this one. I'm going to go to another demo page I created. So you can go to structurizr.com/DSL. You get a sort of demo page, which is a text box on the left and some diagrams on the right. So if I now go back to my example of the DSL, take this, pop it into here. So this web page allows you to basically try out all the tooling. So here's the diagram that we saw before, the navigatable diagram. These are the PlantUML exports. So I've just kind of embedded the CLI into this web page. So this is an example of the PlantUML export. It gives you a diagram and a diagram key. There is a C4 PlantUML version as well, which gives you the kind of standard C4 look and feel. There is a Mermaid export. So Mermaid's quite interesting because GitHub just started supporting the rendering of Mermaid in GitHub README files. There's also an export for the dot format. And if you have dynamic diagrams, you can actually export those to web sequence diagrams. So let me show you that as well. Go back to my big bank example. So here is the dynamic diagram that's a part of the internet banking system example. And the dynamic diagram in Structurizr is animatable. So this is just ordered arrows, which is animatable. And you'll see here there's a web sequence diagram, bit of text. You can pipe that into web sequence diagrams. Just to note, by the way, the PlantUML export of the dynamic diagrams kind of gives you that UML collaboration diagram look and feel. So it's a bunch of free format boxes with numbered arrows between them. You can actually tell the PlantUML exporter to not do that, but to use sequence diagrams instead. How do you do that? What you do is you go down to the diagram definition, which is here. We add a property, which is called PlantUML.sequenceDiagramTrue. So now we can render that. And what we'll get, hopefully, is a sequence diagram version. And that's a nice thing about this tooling. A collaboration style diagram and a sequence diagram are essentially the same thing in a different visual format. So this allows you to use whichever format you like best, which is quite nice. So that's that. We've shown you some of the export formats. Themes. Yes, the support for themes. Lots of people these days are drawing cloud architecture diagrams using the AWS and the Azure icon sets. So let me show you an example of all that stuff. I've pre-built a bunch of themes for Amazon, Azure, et cetera, et cetera. So here is an example workspace. It's basically defining a software system comprised of a web application talking to a database. And it's also describing an Amazon Web Services deployment architecture, which I'm not going to show you there. But this is the diagram you get. So essentially what we've done here is we've used a bunch of Amazon icons, and it's all the same tagging and styling mechanism as you've seen before to essentially use those styles on the diagram. So this is kind of a nice structured way to use those AWS icon sets rather than just kind of blasting out, here's all the services we're using. So this is a much more considered, structured approach. So there's a bunch of pre-built themes as well. One of the questions I always get with this tooling is, well, hang on a second. All your example diagrams are like 3 or 4 or 5 or 6 boxes. How does this work in the real world? How does this work with kind of big, proper systems? So let me boot up Structurizr Lite again against another example I have. And this is kind of like a distributed services style example. So we're going to go back here, open yet another tab. Oh my goodness. So here we have Structurizr Lite. Now imagine you're building some sort of a service-based architecture, and you have a web application and then a bunch of services sitting behind it. Kind of like a distributed monolith, but let's ignore that fact for the moment. And in this example, we've got 8 services. And what I've done here is I've said every service is basically the combination of an API thing and a database thing. And I've used a little gray line to group those two things and use some color coding. So we've got 8 services here. So this diagram's kind of okay, isn't it? This works. Imagine this was not 8 services. Imagine it was like 10 or 12 or 20 or 50 services. This diagram would start to break down quite quickly. So how do we fix this problem? Well, one solution is you don't draw one diagram showing all 8 services. You draw 8 diagrams showing 1 service each. And that's all I've done here. So here's the service 1 version. So what we're doing is we're showing and focusing on service 1, and we're showing things going into service 1 and things coming out of service 1. This is the service 2 version, things coming into service 2, things coming out of service 2, rinse and repeat. So the question is, well, how did we do that? So let me show you the source for that thing. So here's my workspace.dsl file. Here you can see an example of the service I've defined in the DSL. So basically it's an API container and a database container grouped. That's what I'm calling service 1 in this case. And it's just rinse and repeat for all of the other services. Nothing too exciting there, some relationships between them. This is the all container version. So the all container version basically says go and include all of the containers inside that software system. So you get all those 8 services and the web app. And this is the service 1 version. So I'm saying include service 1, include things coming into and coming out of. So the afferent and efferent couplings of service 1. Repeat for service 2, 3, 4, etc. So this is a really nice quick way to craft up a bunch of diagrams all showing like a partition or subset or window into that bigger model. And it's all trade-offs. So this diagram is nice because we can see everything. And these diagrams are nice because we get to focus on one thing and we kind of don't focus and show the things we might not be interested to maybe tell a story. So this is option 1. And as with everything here, you always get a bunch of options. So option 1, if you've got a bigger, more complicated system, is to draw a bunch of smaller diagrams. Option 2 is to click this button. This button opens a nice dynamic D3.js force-directed graph. And it's showing us exactly the same data as before, but we're showing it in a much more succinct, concise data format. And it's nice and interactive. I just love dragging these things around. It's just very therapeutic for some reason. It's got tooltips, so if you want to add additional metadata to these things, you can do. You can click and it shows you nearest neighbors. There's a quick find feature. So yeah, this is kind of option 2. This is a really nice way to explore a larger container architecture. We've got lots of services or lambdas or function apps, for example, or maybe you've got a large monolith with lots of components sitting inside it. So that's option 2. Option 3 is let's shut this down. We can use the CLI tool to export that workspace. So that was a services example, workspace.dsl, minus format, Ilograph. So Ilograph it's a kind of freemium tool. So this is not a tool that I've put together. It's available at ilograph.com. So what I'm going to do is go here, take this file, put it into VS Code. The export that it creates is basically a YAML file. So the input to the Ilograph tooling is a YAML document. Please don't draft this up yourself for obvious reasons of spaces and things. But if I copy this into my clipboard, open up yet another tab and go into ilograph.com. Now we can go new diagram. We can take their example out, put mine in, hide that, click that, hide that. And this is the same data now. This is the same model in the Ilograph tooling. And it looks kind of nice, but it's also interactive. So we can now start clicking around and boxes expand and kind of zoom in and focus. So this is a really nice tool for exploring a hierarchical data set. And of course, the software systems, containers, components is by nature a hierarchical data set. So again, this is a really nice tool that you can use to explore a large architecture. So this is available as a web app, and there's a desktop version, as you can see here. So that's kind of my recommendations for dealing with kind of larger, more complicated real-world software systems. There are a bunch of open source libraries. So all of this tooling is actually built on top of some libraries I built back in 2015 called Structurizr for Java. So all of the tooling I've shown you is built on top of that library, and it's all sitting and running in the JVM. All of the libraries I have actually published to Maven Central. So anybody here who is a Java developer, you can grab and reference those things and build your own project. So for example, I've got IntelliJ IDEA running here, just a bog standard static void main method. We are getting a reference to that DSL file, the YOW example we created earlier, crafting up a DSL parser. We're telling it to parse the DSL file. We're grabbing the workspace. So again, this is like an object model. We're grabbing the workspace that is created by parsing that thing. And now we can just, in this case, iterate over what's in there and print it out to the console. So if I run this, and scroll up. So here we can see it's dumped out all of the things that we defined in that DSL file. Now, you might be thinking, well, that's not particularly useful. Like, what's the point of having an ID and Java integration? What you can do is you can do things like this. So let's get a reference to the web app. How do we do that? We can ask the DSL parser. So there are a couple of ways to do this. You can either traverse the model and find the element you're looking for. You can just ask the DSL parser to go find it for you. We can get the identifiers register. We can do get element by its identifier. We call it web app. So that gives us a reference to that web app container we defined. And now we can say web app.add component, logging component. So now we've appended to the model. And if I run this, now you'll see this logging component shows up. The nice thing about this, of course, is now what you can do is you can craft up a high-level DSL file maybe of people and software systems and containers. And if you have a large, say, Java monolith, you can write some code, load in that model, find your monolith as a container, and now you can use Java's reflection or static analysis or some of the libraries out there to go and find your components that exist in your actual code base and insert them into the container. Then you can dump out the JSON version of this document, and now you have a model which is partially manually specified and partially automatically created. You could also do the same thing with like your AWS environment. So you craft up your entire architecture, and then you write some code to go and scrape out your AWS config or your Azure config, and you build up a deployment model based upon the containers and software systems in your DSL file. So that's the Java version. There's also a bunch of libraries for other languages. There's PHP and Python and TypeScript, and I wrote a .NET version a long time ago. The DSL parser is written in Java, so we don't have access to the DSL parser in C#.NET, but what we can do is we can instead load up the JSON document. Most of the supporting libraries work with the JSON thing. So we can basically say, go load the workspace via the JSON file and do the same thing. We'll just go and iterate over the various things in the model. So now you have a way, again, to start integrating some of these tools into your build process, which is quite nice. The kind of final thing I want to show you is scaling. So when I see organizations using this tooling, they normally start out using it in a single group, and then other people, other departments, other teams want to also kind of get on top of this tooling. And then the question becomes, well, how do we start reusing elements across teams? Now, this is really hard to do with something like a visual modeling tool, because you have to kind of put your entire enterprise model into one visual modeling tool, and it's not a very good idea. So what I'm going to show you here is a feature called Workspace Extensions. Let me start up Structurizr Lite again against a different example. I'm going to leave that running in the background for a second. So here's my workspace extension folder. So imagine we have a DSL file where we're defining our system catalog. In this case, we're defining all the users, the actors, the roles, personas, the people that exist in our enterprise landscape, and all of the software systems that also exist in our enterprise landscape. You'll see people doing this a lot with tools like Backstage at the moment. And there are some interesting conversations going about how we integrate this tooling with Backstage, because there's some overlap, of course. So we have our catalog, and this is a list of all of the people and software systems that exist in the landscape. Now what we can do is we can say, right, team one, what I'd like you to do is craft up a DSL file for your system, and what you're going to do is you're going to extend that catalog. You're going to find the reference we created to software system one, and you are going to define the things that live inside your software system. So one of the things I talk about when we're defining software systems is you'll often find there's a team or ownership or responsibility boundary associated with a software system. So here we're saying to the team, go and craft out your description of the things that sit inside that software system and craft up any diagrams and documentation that you need to do in order to visualize it. So now if I go back to Structurizr Lite and I boot up the example we just started. So here we have a context diagram and we have a container diagram, and this is basically what was defined in that definition. So we've got a link here between user and the web app, does thing one using. And then you say the same thing to team two, go craft up your own workspace, stick it in Git somewhere, extend our central catalog, and craft up whatever model and views you need to describe your software system. So now we've got one user, and that one user is using both software systems. And that's cool, because now every team can kind of do this individually in turn. But what happens when we want a view, a breakdown of the whole landscape? Although all these teams want to run in isolation, I often find enterprises do want some sort of overriding picture of all of the systems and all of the user types. So how might we do that? Let's start Structurizr Lite back up again against a system landscape folder this time, which is this one here. And in the system landscape folder, what I'm doing is I'm saying I would like to extend the catalog and craft up a system landscape diagram. Now what this is going to do, of course, is it's literally just going to draw a diagram with the things we define in our catalog, the two software systems and the user, which is not particularly useful because there are no links. All the relationships are defined in the child workspace, the System 1 team's workspace and the System 2 team's workspace. So how do we fix this problem? Well, we could ask all the teams to also move and copy their relationships up to that catalog workspace, but that doesn't seem like a very good solution. So this whole tooling supports the ability to write scripts in JVM languages, so Kotlin, Groovy, and JRuby. And you can also write plugins using some of the Java interfaces stuff. And what I've done is I've written a plugin. It's called Find Relationships plugin, because it finds relationships. I'm going to save this and refresh. And now what it's doing is it's loading all those child workspaces, figuring out what the elements are and how they match up with the catalog. And it's pulling all of the people and software system specific relationships back into that top level workspace. So again, this is a really nice way to allow your teams to craft up their own documentation diagrams individually, but still have that big picture if you want to. And that's kind of the sort of thing I see doing. Large organizations often want something like a system or service catalog. So that's pretty much all I wanted to show you from a kind of demo perspective. And my last slide is, if you want to get started, you can go to structurizr.com/DSL. That gives you that demo page with the text editor and all the different diagram formats. You don't have to install any tooling to do that. All of the DSL parsers are all on GitHub, the underlying libraries on GitHub. The exporters to PlantUML and Mermaid are also Java code on GitHub. There's a link to the Structurizr Lite Docker container that's going open source next year. C4Viz is on GitHub, and the Structurizr Sites generator is also on GitHub. Thank you very much.
Thank you, Simon. It's good to see someone had a productive lockdown.
I did.
I think most of us just learned how to make banana bread.
Banana bread.
Do we have any questions? It's got to be up the top corner.
Yeah, it's the furthest corner away.
Yeah, thanks for the talk, Simon. I found it very compelling. I really like diagrams and trying to do a lot more of that in my company. I had two questions. First one is, have you thought much about like CI/CD support and how that would work? And the other question is, have you thought about like IntelliSense support in the DSL in VS Code or something like that? Yeah, so question one, CI/CD support. If you go into GitHub, a bunch of people have already built GitHub Actions. So because all of the CLI tooling is just command line tooling, it's really easy to integrate. So you look for a commit, trigger on commit, run the CLI, do stuff like generate PlantUML diagrams. And if you have the PlantUML tooling installed in a Docker container, you can just go generate those diagrams as PNG files, for example. So CI/CD is super simple. Question two, IntelliSense and things. If you go to the DSL GitHub repo and scroll to the bottom, you'll see there are a couple of VS Code extensions. They don't do IntelliSense, but they do syntax highlighting. I found somebody recently who's actually building a plugin for IntelliJ, which I think is going to do completion. So that's not something I have time to do, but it sounds like somebody's building it, which is going to be awesome.
Thanks, Simon. That's really interesting. Has someone else claimed the file extension .dsl?
Yeah, probably. There's no There's no kind of mandated use of .dsl in the tooling. It's just I chose to use .dsl. If you want to use something else, that's absolutely fine. Naming's hard.
G'day, Simon. Thanks for building Structurizr. I used it recently.
Cool.
One of the things that I found difficult, though, was at the different levels of the diagram, so like the system context versus the container context, sometimes you want to have more detailed relationships at different levels.
Yep.
Like, or more relationships and so on. And so, yeah, I just sort of struggled with coming up with the right level of detail because, like as you said in your presentation, you can have inferred relationships, or I think that's what you called them. And so if you do that for a lot of things, you end up with a lot of lines on lots of different diagrams and things. How do you recommend sort of structuring your DSL so that you end up with the right level of detail at the right diagram?
Yeah, sure. So if you've got, so say you've got like we had here, we had the user talking to the web app. Imagine that the user is doing like 3 or 4 different things. So something you do on your user to system diagram is you say the user does a bunch of things. So you kind of summarize all the relationships on the high level diagram. So that gives you a nice simplified context diagram. And then maybe you have each of those individual relationships defined at the container level. Now, I actually wouldn't recommend doing that because you get lots of clutter. So what I'd recommend doing is perhaps think about summarizing the relationships on the static structure diagram, so the context and container diagrams, keep those quite general. And then for every interesting kind of use case or story or feature that you want to elaborate, you have a bunch of dynamic diagrams that show an individual feature. So the dynamic diagram basically allows you to showcase relationships that exist in the model, and it allows you to override the text, so in other words, be more specific. So that would be my advice there. If you drop me an email, I actually wrote a blog post on dev.to that describes this whole approach and strategy. So that's a nice way to clean up your relationships.
Any other questions?
Yeah, thanks for the talk. I really love the tooling. I've played around with it a few times. I don't know if this has a short answer, but like the thing I struggle with is like, how do you apply that in your company? So you got to learn how the tooling works and things like you've just showed, but then any company will have their own language for what are systems, what are containers, what are components, and various resolutions of modular monoliths and microservices and things. Like, how have you observed companies go about like forming that common language that they can then represent in these diagrams?
So the honest answer is most of the customers that I work with and do workshops with, they just adopt the C4 terminology, so software systems, containers, components, and code, and they really only focus on the top 2 levels in terms of diagrams. One of the biggest things I have seen is that teams and organizations don't have that same terminology. So Spotify, for example, wrote a blog post a couple of months ago on their engineering blog, and they used the C4 approach, but they actually have different terms, and I've seen other organizations also use different terms. From my perspective, that's fine. So this tooling allows you to reword the terminology that appears on the diagrams. So you can still use this tooling and have a bunch of different names if you want to. So that's kind of approach 1. But generally, actually, I see most people just sticking with this terminology because it's kind of easy and straightforward and it's lower barrier to entry.
Maybe time for 2.
Hi. This comes from a previous encounter with a colleague of mine. You've previously made a comment that certain frameworks weren't long for this world because they were hard to diagram in this system, and it was evidence of architectural smells inside those frameworks. Do you have any more commentary around that?
What was the comment?
The comment was that there were certain frameworks that weren't long for this world because they were hard to diagram inside of C4, which was evidence of architectural smell inside those frameworks. Do you have any commentary around analyzing architectural smells using this diagramming tool?
So do you know where that comment came from? Because I don't remember making it. Was it in a bar somewhere?
I believe it was a workshop in Canada.
A workshop in Canada? I've only ever done one workshop in Canada. So it narrows it down. In terms of identifying architectural smells, so, I mean, things like frameworks are not good to model with the C4 model because this is really for modeling systems and apps, and frameworks are things you kind of embed in systems and apps. So if you want to describe frameworks, I would use something like a UML class diagram and a bunch of sequence diagrams. In terms of architectural smells, yeah, if you have a components diagram and let's imagine you think of your web application to be a bunch of components organized into layers and you want all the arrows to go downwards. Imagine you automatically generate your component diagram and arrows go all over the shop. Right? That's a really good, simple way of seeing you've got some kind of code smells there. So really, it's about looking for the relationships and looking for the patterns you expect to see. And something you could do with this tool is once you've used something like a static analysis tool to load in information into this format, you can then write a bunch of unit tests to make sure you have assertions where relationships only go one direction, for example. Yeah, feel free to grab me about the framework thing, because I'm not sure where that came from.
Hi, that was really interesting. Perhaps this is an abuse case, but has anyone investigated using giving live status of the systems you're modeling? Yeah.
Yes. So there is actually a health check feature. So when you craft up your deployment architecture, you can associate HTTP health checks with container instances. So if you're deploying like a couple of web apps, you can say point a HTTP health check to those web apps, and if you get like a HTTP 200 OK, it will turn those boxes green, and if it doesn't, it turns it red. So yeah, that's actually partially built into this. I do want to extend and add some features around that use case, but yeah, it's doable now actually.
Excellent, thank you, Simon. That's it for today. Join me thanking Simon again.
Thank you.